Welcome to watch the brief introduction of our paper, Video Perception Models for 3D Scene Synthesis. Existing scene synthesis methods face notable limitations in generating realistic layouts. One promising direction involves leveraging large language models, which typically translate linguistic priors into layout constraints. For instance, holodeck often produces incomplete spatial specifications and treats scene synthesis as an optimization problem, which can result in the loss of spatial common sense. Here we show an example where the chairs and table block the window. Alternatively, image-based approaches, like Architect, adopt specific viewpoints and apply recurrent and painting strategies to directly exploit visual priors for common sense layout generation. This method, however, often suffers from hallucinations and spatial inconsistencies due to viewpoint dependency and the iterative nature. Here, we show a scenario in which additional chairs and tables are hallucinated. Recently, video models have demonstrated the ability to generate diverse daily scenes given image or text prompts, which aligns with human preferences well. In this paper, we propose leveraging these video models for common-sense layout reasoning and consistent viewpoint coverage to overcome the aforementioned problems. Specifically, the user is asked to provide either a text description, an image demonstration, or both. Based on this, a video generator creates a realistic video clip. A feed-forward 3D reconstructor recovers the holistic 3D geometry of the scene. Meanwhile, a 2D detector and tracker identify and track the elements described, lifting the mask and bounding boxes to 3D space to segment the point clouds. Using these per-object point clouds, an asset retriever retrieves the most relevant asset objects from a large database based on visual similarity, textual relevance, size similarity, and point cloud registration. Here are some examples provided by our method. Additionally, existing metrics for 3D scene synthesis benchmark performance by scoring single top-down renderings using VLMs. This perspective may obscure important object details and hinder accurate semantic interpretation. In contrast, we propose using a virtual camera to capture a 360 degrees egocentric visual field for VLMs to score. This first-person view offers a more interpretable and human-aligned evaluation. Specifically, we render frames at 30-degree intervals to ensure comprehensive coverage. These frames are horizontally concatenated to form a compact visual summary. We stack the summaries for scenes generated from all competing methods and input them into the VLM simultaneously, avoiding inconsistencies that could arise when evaluating them in isolation. We design a structured prompt to assess scenes in terms of semantic correctness, layout accuracy, and overall coherence. We further instruct the model to justify its ratings with brief explanations, enabling verification of its reasoning. Finally, we show some comparisons among Holodeck, Architect, and ours. Thanks for watching. Please visit our website and paper for more details.